My name is Jun Liu. I am a Senior Marketing Manager at Revvity Signals. Today, I want to talk about our formulation capabilities currently available and also what's coming on the horizon. I want to talk about some of the cool features that will really support the formulation workflow that this audience will find useful. First, just a little bit disclaimer. Some of the feature screenshots you will see in this presentation are still under development, so just keep that in mind. I want to organize my presentation in the following way. First, I want to talk about the idea of forming a consortium to really drive our software development work. And the second, because data table is such important component of representing a formulation, I want to talk about how our current admin-defined tables can really help to represent a formulation. And then I want to talk about how we will go from representing one table formulation to various formulations within the same design of experiment. And then I want to conclude this presentation with some roadmap presentation talking about our near-term and longer-term future plans. So let's get started. First, for any software company to succeed, it's very important that we start with our customers. We keep what our customers really want and need in mind. We start there and then we finish there. So Revvity Signals is no exception. That's why we designed this customer-centric process to really first by understanding what are the most urgent and common and important use cases that our customers are facing. And then from there, we work with professional service teams to really integrate these use cases from different disciplines and from different users to really define what our software solution should look like in order to deliver. And then product team comes in to propose a design and then design a software, build a software, test it, and then we do a beta version demonstration in front of a selected group of customers to get their feedback. And then we repeat this process again and again in order to develop features that are really useful to our user base. So throughout this process, we establish multiple touch points between our customers and the various teams within Revvity Signals. And this process is what we call a consortium. And while we think that process is really important, we are also keenly aware that there is a large spectrum of users for our data management solutions. At the same time, our data management solutions have to service a large variety of scientific disciplines. And in times, these two objectives may come at odds with each other. So it's very important for us to keep in mind that what are the most important elements of software design that we should propose to really satisfy a majority of our user base. So we think in these two aspects, our software absolutely have to deliver. One is we do everything we can to really create and improve a streamlined user experience. So scientists, formulation scientists, and various other disciplined scientists, they really enjoy our software. And then the second is we try our best to support as many kinds of scientific workflows as possible. To name a few here: process chemistry, formulations, fermentation, and many others. Because there is some commonality between different scientific workflows, and we do our best to really support all of them. So with the process in mind and with key objectives nailed down, and we established these 4 goals as the reason why we think forming a consortium, inviting our customers to our development process is the best way to go. The first goal is really we want to create a pre-competitive or non-competitive community for our clients, where ideas can be exchanged and we all benefit from the openness and transparency of this community. And the second, we try to build a consensus on the challenges businesses and scientific community are facing that Signal Notebook and the Signal Research Suite can really help to address. And then the third goal is to really iterate on the design and the definition to really deliver a really very, very good solution to our users. And then fourth, it's really consortium provides the best way to give transparency and the visibility into the process and for our users to know where we are, and also for us to keep a pulse on our users. So that's for the consortium idea. Next, I want to talk about ADTs, or admin defined table. As we all know, formulation involves a lot of tabular form of data representation. So we spend a lot of time thinking about how we could design a powerful and yet flexible and also managed data structure to really represent formulation data. And in our software design, we call that data design admin defined table. It's basically a data table. I mean, in my language, I tend to think ADT means advanced data table, but we leave that for another discussion. So that's where we start. But in order for a data table to make sense, right, it's very important for formulation team to not only keep all the data part of formulation, but also record context. So in our software design, we want to make sure that from the start of an experiment, such contextual information and the metadata are captured and organized in a structured way. And then that information is kept throughout the entire project, and the teams can always go back and make modification, can check what's going on. Everything is managed. So the first step of formulation using our software is this create experiment stage, where team can design a template to really provide a structure to define various aspects of a experiment. So, and also we make sure we follow a certain rules and record as much information as possible to meet various GXP requirements. So that's the start of a formulation. And then when the team is ready to create a formulation table, we provide powerful tools for formulation team to create their own template of ADT, element-defined table. In this example, this is one of the templates ourselves we designed to validate our formulation capability. Here, basically, each row represents an ingredient, and each column represents a specific data point related to that ingredient. And combined, this table represents a formulation. And there are predefined columns, there are user-added columns. Depending on the needs of the team, this table can be configured in the way to best support the way formulation workflow is conducted at your company. And then when this table is defined, the user can go in and add specific formulation content into this table. So again, as you can see, each row represents an ingredient. And we also added capability for numbers to be calculated. And also, as you can see, the purple hyperlink here, each purple link is a hyperlink to another data container in a database, whether it's internal database or external database. In this case, raw material RM0128 is connected to inventory management system where property information and even physical location of this certain raw material can be found, and the information can be imported into this data table. And the next step is to define mixing procedure, right? We all know in formulation representation, representing various components of a formulation is only half the battle. The other half is describing how these ingredients are prepared, how they are mixed, what are the mixing conditions, what are the mixing equipment, and all those details matter. And to support that work, we provide a team also to use a ADT type of data structure to represent that mixing procedure. Here is described as a protocol. So just like formulation table, this table also supports data link to various locations. And also behind this table, task management system can be connected. So tasks can be issued, and the tasks can be connected to formulation, to procedure table, and everything is recorded and work can be reviewed. So we really try to provide an integrated system to fully support the formulation workflow. And in addition to representing ingredients and mixing procedure, our inventory management system or raw material management system also has capability to record various material-related property information. In this case, SDS is stored in the system, and we also provide, in our latest release, the capability to auto increment and decrement the amount of ingredient used, and also physical location of the ingredients can be traced in the system. So that's we connect experiment record with material library to try to give formulation team a comprehensive view of what should happen to make a formulation. So that's a key feature in our experiment, in our formulation workflow capability. And as I explained earlier, mixing procedure is an important part of formulation work. And for more complicated workflow, for more complicated procedure, we designed a tool called worksheet, where the team can design specific steps of achieving a sample preparation, given and following certain practices within the company. We provide a tool for the team to really specify each step of that sample making work and connect to both formulation table, to recipe table, and even to inventory management system. So to make the whole formulation representation a whole. And then the last step of an experiment, we provide ability for the team to really lock a formulation by asking for signature or approval on the work. So that's what we think can really help formulation team to first represent a formulation, but also to create a container, to create a structure that captures not only the data portion of a formulation, but also the entire formulation workflow. And doing that, I think we add extra layer of IP protection, quality assurance, right? And also provide the team a good tool to really collaborate with each other, review each other's work, and manage various tasks that are happening along the formulation work. So the next component that we currently provide is the ability to take that data in formulation table and put it in our data analytics and the visualization engine, which is Inventa, that is backed by Spotfire. In this example, once the formulation data table is defined, mixing procedures defined, samples are made, and various tests are conducted, all that data can be imported to Inventa for further analysis. Here, this slide shows a few examples of different charts that Inventa can do. On the left, you can see there's XY scatter chart colored by formulation, representing relationship between dry to touch time and also viscosity. And also in the middle, you can see price or cost per formulation comparison between various formulations. And on the right, you can see composition of select formulation. And also you can compare them side by side. One thing I want to point out is this is a very scientific driven data engine. And also all these charts are interactive, meaning you can go from data to generate a chart, and then you can select the different portion of the chart and get additional data table. So it's a very, very powerful data analytical engine. Again, there are many other types of visualization and analytics you can do using Inventa. So essentially, we want to provide formulation team a predictive analysis tool, so you can visualize current formulation, and then based on that, using various ANOVA analysis method or as simple as linear regression to further refine formulation to really improve it. Doing that while having visibility into total formulation cost. So I want to say Inventa has a rich array of interactive charts. Okay, so that's what we provide today. So in the near future, we are working on going from one formulation table to a number of formulation tables within the same design of experiment. So the basic idea is DOE usually start with a few formulation tables, and these tables need to be compared, calculated in various ways, right? And then from there, experiments are conducted, and then testing is performed, and the additional data is collected and then used to drive next round of formulation improvements. So we want to make sure we can support that. We support that first by having a table that defines different ingredients in a formulation. In this example, the first column is ingredient used in this formulation. And then once that's defined, we want to design a way for formulation team to go from one formulation to multiple formulations using the first call it parent table or root table defined as the like a template. So in this example, once we define components in a formulation based on that component table, different formulations can be created and compared, and while all this work happens in a managed style. So, and then the last tab shows, okay, now we have components defined. We created different variations of that table, and we also provide designing tools to compare different formulations, whether we do that by component or compare different ways, compare how these different ingredients are added. We want to provide a flexibility for the formulation scientists to really understand and identify the difference between various formulation table variations. So in this case, data goes from left to right, but we want to make sure that such view can be transposed, so data can go from top to bottom. This is still under development, so if you have any suggestions, if you think there are certain ways that your company does things that's right or that will benefit the entire scientific community, please get in touch with us. We are open for ideas. So we talk about formulation table, we talk about variation of formulation table. So now let's look at what's in our pipeline in terms of formulation capability. So the green boxes are the functions and the features that we have implemented or we have implemented the majority of, and the blue boxes are what's on the horizon. So starting with calculation enhancement, and we have added in our latest release many excellent functions to really help calculating between cells, and also to add some logic into row calculation, such as if, sum if, taking average, and calculate the standard deviation type of calculations. So I want to say our formulation table today, or admin defined table today is much more powerful than just a few months ago. And then from there, we are currently actively working on variation table or multiple runs, as I explained earlier. So the idea here is to represent multiple formulations in one experiment, and then provide the data import-export capability, and also allow users to really view and compare different formulation tables easily, and provide that flexibility. And then going near future, what we want to do is to really make formulation library some sort of a data type or a data object. So basically, given formulation team a way to treat each formulation as its standalone object, and then all the good work can happen after that. So we are working on making formulations persistent, and also provide other ways to represent a formulation library. Right? We're doing a very good job at representing one table, at representing one formulation. But now we are thinking about how do we represent a DOE properly? How do we represent a collection of multiple formulation tables in a scientific and user-friendly way? I think that will go a long way. So the work is happening. We should be seeing something as early as maybe next year. And then from there, we want to make sure we take this formulation library idea all the way from notebook to inventor. So we will work on additional data import, export features, and analytics and comparison to really take the data portion of a formulation out of notebook and into inventor, which is a key component of research suite. And then additional ideas we are still trying to define, and also I think it will be very soon we will work on it. It's also how to handle premixes, right? Or how do we insert a table into another table? I mean, this is a common way of working in the chemical industry, in the formulation. It's taking a existing formulation and then insert it into a new formulation. So how do we basically insert a data table into another data table that may have different columns? How do we keep integrity of both tables while allowing that flexibility and convenience? I think it's going to be key for formulation team. And in the long term, we also want to make sure this data pipelining idea and other features are also a part of our formulation roadmap. So we have done a decent job in calculation enhancement, and we are working right now very hard on variation table. And then eventually we want to work on formulation library object representation, and then make the data manipulation and the data import and export and the premixes much easier for our formulation scientists. So that's what we plan to do, and we are working very hard to deliver this. I understand our customers have very high expectations for us. If you have good suggestions, have ideas, please don't hesitate to let us know. Personally, I'm very passionate about much stronger formulation capabilities and the features, speaking from my computer science background. So I want to thank you for coming to my session, and stay tuned. We also have many other wonderful presentations coming up. So thank you, and yeah, if you have any questions, please ask during the Q&A session. Thank you.